many numbers would you need to describe the moon? The moon, to begin with, let's part more with the word. Impacts. To characterize each precisely, two coordinates, latitude and longitude, every one of thousands of traits is aligned with the size of its crater. Very rapidly, we find ourselves needing thousands of numbers to describe a moon even before we start chemical compositions of the moon surface and how that varies in the number of numbers we need could expand from thousands to millions and beyond and beyond. And that is just the moon, one of the comparatively more simple objects in the cosmos. How many more numbers would it take to describe a planet, a star, a nebula? Or indeed, how many numbers would it take to describe the most massive single object in the entire universe, a black hole? The answer for these monsters may surprise you. Three numbers and no more. No matter how heavy they are, no matter where they were formed, no matter where they are in our Milky Way galaxies or a billion light years away, three numbers, and only three, are sufficient to define them completely. On the one hand, this makes black holes seem like very simple objects. Only three parameters is necessary to classify them: their mass, electric charge, and angular momentum. Now there's three more. You have everything, and yet there are enormous to form a black hole. They can be formed by gradually swallowing up over billions of years. They can be formed by the direct collapse of a massive star in a type 2 supernova. Perhaps yet another could grow through a merge of other black hole pairs. We could even imagine a hypothetical black hole formed from the contents of every encyclopedia and every electronic databank of every civilization in the galaxy. Every piece of information, every single number ever thought or said by anyone ever. Anything and everything in the universe can go into a black hole, and yet once it is formed, all of that information is reduced to three numbers. How the black holes was made, and what went into it becomes almost irrelevant. And so the question is, given these almost uncountably large number of possibilities for making a black hole, how can they then be described by just three numbers? Where is all the other information gone? Has the black hole forgotten about its origins, or does this information survive in some hidden form? Just what is inside a black hole? And what could it mean for the rest of the universe? Many of the atoms, who you are, can actually be traced the very first second of the Big Bang, 13.188 billion years ago. It is fascinating. We can trace our true origin. That's why my heritage must sign up for husbands. My heritage makes finding music, family tree, and discover your origin. Find new relative, my family. British I'm still surprised. Typed in my father's mother's name. Birthday. My system, my family tree. Someone in Australia. Rates of relative I never knew about. Logging on my family tree. 72 people, as well as this. Match this with someone of my other side. I knew cousins in the USA, my family, widespread than my thought. My heritage, worldwide leading family history service. 20 billion records available. And indeed, I've never seen before. It is a bone. Colorize our photos are like this. To bring your family back to life. We try all the amazing has to offer. Thanks to my heritage, supporting educational content on YouTube. In the 1780s, country priest in the Church of England was especially demanding a large house with a decent group of servants to do the household chores and younger curates to take services and visit the sick to those who wanted it. A leisure was on offer. Something more. There was time to think deeply about the world around them. And this English parson John Mitchell spent his time. By the 1780s, Mitchell had a pretty good idea how gravity worked. Isaac Newton's theory of universal gravitation that shocked the scientific world. Gravity was a universal force, and that had mass gravitated and everything else. Nothing could have worked with gravity like itself. Light, time, individual particles, little atoms of light, or photons. If light as particle was true, gravity was universal, then gravity should be active on these tiny particles of light. tugging at them and pulling them back. Mitchell also knew that the light traveled fast, very, very fast. Indeed, earlier in the 18th century, the astronomer James Bradley had measured the speed of light and measured it well and accurately through thinking about the aberration of light from distant stars as the Earth moves through its the velocity of the Earth and the velocity of changes tiny amount, very slightly, the stars in the sky. Through this, the speed of light was now 100 miles per second. This was fast, but not infinite. And finally, intuitively, Mitchell knew that an object thrown upwards would fall back down. Fast enough. This does not happen. Instead, it is enough speed to escape gravity and launch space. The threshold value, known as the escape velocity, is the minimal escape and reach infinite space. It's an easy calculation. Gravity for escape velocity, any given planet, density of the object. The more massive the object and the more densities, the bigger escape velocity. For example, for the moon, this escape velocity is around 2.5 kilometers per second. Kilometers, 60 kilometers per second for our sun strength per second, roughly. But imagine an even denser body. What about a body that has sufficient escape velocity to exceed the speed of light? Such a body, like a method escape. In this case, such a body would appear gravitationally massive, very timely dodge, even like. It is Newtonian physics that would be replaced by Einstein's theory. It is describing. It's clearly recognizable. 3 centuries. First description of black hole. But Mitchell was way ahead of his time, and it resulted in the curiosity, scientific background, and stayed there for 150 years. But the next time this drawer would be opened would be in the miserable trenches of the First World War, where the German astronomer Constantly Mescal surrounding him pondered the equation of the brand new theory of general relativity. Having developed his special theory in 1905, 10 years later Einstein succeeded in extending it to include gravity, constructing his general theory of relativity. This theory requires 10 equations to describe it, written down, formidable and almost impossible to solve. solve them. Let's watch. Simplest possible solution you could imagine. Spherically symmetric space-time. Concentrated point-like mass. Plugging everything in. Calculating everything between the solution. Schwarzschild solution. Probably the most famous solution in Einstein's equation. Schwarzschild solution involves one parameter, the uniform spherical mass. General relativity less the form. سلام خسته نباشی قربان یه برای تکرار میگیریم there is little change قیمت ها فرق نکرده بگم قیمت ها فرق نکرده مثلا center of the black hole
نگاه نمی‌کنم بله خب کامرا میرسه اون کی بود رسام یعنی اگه 50% استفاده کنه این ترم همش ترکه ولی خار برامن رو بازیه پرسپولیس برای دور برو بشین.